Okay, now let's find the equations of geometric sequences. If you'll go back and watch my video about exponential functions and finding those equations, it makes this a whole lot easier, and they actually help explain each other. So again, my equation, a sub n, since it's a function, or excuse me, since it's a sequence, will be, again, whatever number you start with. Let me just make one up here, 2 times 3 to the n minus 1 power. So this sequence, if I were to plug it in, if I plug in to find my first term, you'd plug in a 1. 1 minus 1 is 0. That means 3 to the 0. That kind of goes away. My first term would be 2. My second term would be 2 minus 1. You're going to multiply by 3 one time, which would be 6. If you were to plug in 3, that'd be 2 times 3 to the second, which would look like this. So what is happening is you're multiplying by 3, an extra 3, over and over and over. And notice that doesn't match. So that's not the right answer here. I just wanted to give you an example of a geometric sequence. Now, these are really easy, though, because if you understand what this says I start with the number 3, and I multiply by the number 2 over and over and over. That's your equation. You're going to start with the number 3, and you're going to multiply by 2 over and over and over. That power will always be n minus 1, because if you were to plug in, let's say, you look for the third term. If you do 3 minus 1 gives you 2. You're going to take the number 3, and you're going to multiply by 2 twice. And that's what you do to get to the third term. You're going to multiply by 2, then you're going to multiply by 2 again. Well, how do you get to the fifth term? You'll multiply by 2 4 times. So that's pretty simple now to find these equations. Like here, a sub n will equal, you're going to start with 8, and you're multiplying, well, notice you're halving it each time. So your common ratio is going to be 1/2 to the n minus 1 power. That's it. Number 5 gives you a third term and a ninth term. So your third term is 4. Your ninth term is 128. So pretty much what you're doing from 3 to 9 is you're going to multiply by some number 6 times. Okay, you're going to take that 4 and you're going to multiply by some number. We're trying to figure out what that number is 6 times, and it's going to give you 128. Now, what this equation's doing is this is going to tell us what that common ratio is. Step number 1, let's divide by 4. Gives you x to the 6th is 32. And when you take the 6th root of 32, you're going to get a value of 2. So therefore, this is my common ratio. You can call R, I called it X in this equation, that's fine. So what I need now is to try to figure out, well, what value did I start with? And the easy way, since you're given the third term is 4, so that's going to be first term, second term, third term was 4, fifth, sixth, seventh, eighth, ninth term was 128. Well, why not just go backwards to figure out what that first term is? Divide by 2. Divide by 2 again. So your first term must have been a 1. So your equation, a sub n, is going to be 1 times 2 to the n minus 1 power. Okay, let's work one more like that. A geometric sequence whose second term is 5 and whose sixth term is 300. So the second term, I'm going to write it as points. The second term is 5. The sixth term is 300. So to get from the second term to the sixth term, to find that, and we can call it an R if you want to, we're going to start with 5. We're going to multiply by some R value 4 times, and it's going to give us 300. Divide by the 5, it gives us R to the 4th power is 60. We're going to take the 4th root of 60, and that's going to be a value of approximately 2.783. Now, it gives us the second term, which is 5. So to go backwards, well, let's talk about this. To go forward, you're multiplying by 2.783 over and over and over. To go backwards, you do the opposite. You would divide by 2.783 over and over and over. So since your second term is 5, we can take 5 and divide it by that 2.783, and we would get approximately 1.797. And again, the reason I did that was so that I could find the first term. So now you have your equation. The first term is 1.797, and you're multiplying, this is a horrible equation, you're multiplying by 2.783 over and over and over. And you can check that. It says your sixth term is 300, so you should be able to plug in 6. raise this to the fifth power and multiply by that, and it should give you that 300 or something really close.